Okay, so by now we're familiar with the properties of square roots, how we know how to solve things that have a squared term in them, and we know how to do that using the square root property and completing the square on a perfect square trinomial. Now that's nice, but not every trinomial is a perfect square trinomial, and it's not always easy to turn that into one. So there's another technique called the quadratic formula that we can use to solve any quadratic equation. So this is... Oh, I don't have my pen on. Oh, hang on. Oh, this is annoying. Sorry about this. Wait, hang on 1 second. We can use this to solve any quadratic equation. Okay, so it doesn't matter that it's a perfect square trinomial or not. We just have to be able to solve it. Okay, and it is the most useful, although it's also, to be honest, I find it to be a lot of labor. And it's a long equation, and there's lots of chances to make little sign mistakes and whatnot. So I would suggest, when possible, to try to use that completing the square technique. It actually is really elegant if done properly, and once you know how to use it. Anyway, the quadratic equation, a quadratic equation in standard form, we know this is ax squared plus bx plus c equals 0. And this is just giving us an example with these numbers. Now, here is, in all its glory, the quadratic formula. You will want to memorize this. You will want to know this. You will want to write this on your 3x5 card. And this, by the way, this doesn't come about magically. This formula comes about from actually taking the... Oh, actually, they've got... What are they doing here? Oh, yeah. If you take any quadratic equation in standard form, ax squared plus bx plus c equals 0. And if you were to actually do the completing the square technique to this equation, that is how you derive this formula. I'm not going to derive it on this video. I could, but it takes a while, and you might not care about all the nuances of the math. If you are, it actually is in your book on page 528. It is, the derivation is done for you, but you would basically go through that exact process. We want to have the x squared by itself, divide the whole thing by a, and then you go through and you take half of b over 2 and square it, add it to both sides, continue to solve this for x, and you end up with this. You end up with the quadratic formula. That's where it comes from. It comes from taking the standard form and solving it by completing the square. Now that you've got this formula, minus b plus or minus the square root of b squared minus 4ac, all of that over 2a. This you can use to plug in any quadratic equation. You simply can solve it by plugging in your a for the a, your b for the b, your c for the c, and solving for the x. That's what you're going to do. It's really simple. You just have to know the formula. So here's an example. 2x squared equals 8x plus 90. We want to rewrite this into standard form. So we rearrange it. We minus 8x and we minus 90 from both sides. You end up with 2x squared minus 8x minus 90 equals 0. Fantastic. Now, we don't even care about if the coefficient is 1 or not. We don't even care, because as long as we can figure out what a is, what b is, and what c is, we simply have to plug them into our formula. And just go ahead and plug and chug. Just plug and solve. That's all it is. The only mistakes you can make here are watching your signs. So for example, b is minus 8. But right off the bat, you're taking minus b. You're taking minus 8, right? And then it's plus or minus. Plug in. By the way, this should be minus 8 squared, but minus 8 squared is the same thing as 8 squared. And the way I like to do it is I like to put that minus sign for the 4ac, and then I just always put everything I'm multiplying in parentheses, and then I just look at the number of signs. So it's minus times a minus, minus times a plus times a minus is going to be a plus, because it's a negative times a negative. You want to make sure you get your sign for this term right when you do this. Anyway, in this case, 8 squared is 64. 4 times 2 times 90 is 720. Calculators are fine for this. Combine those, you end up with x equals 8 plus or minus the square root of 784 divided by 4. Again, you can use your calculator to determine this. This happens to be the perfect square. The square root of 784 is a perfect square. It is 28 So again, 8 plus or minus 28 divided by 4. This is now technically, well, this is, again, make sure you just do the math here, right? But it's the same thing as two solutions, x plus 8 plus 28 over 4, 36 divided by 4, and 8 minus 28 divided by 4, or minus 20 divided by 4. So the solutions are minus 5 and 9. And again, for me, I would want this to look like this. Or I'll actually even take this. I don't really care. Okay, so that's really all there is to this. Now, you can be given any quadratic formula or quadratic equation and go about this procedure using the quadratic equation. So the quadratic equation, oh, what's going on here? Oh, sorry, I had to pause that for a second. I had some other stuff happening behind me. Okay, you can rewrite this into standard form. Let's look at this one on the right here. We have minus 9x squared. We're gonna plus 6x, and we're going to minus 1 on both sides. You end up with 9x squared plus 6x minus 1 equals 0. Now it's in ax squared plus bx plus c form. That's a 9. It looks like an a, but that's a 9. Okay, now all you have to do is plug that into the formula. Minus b plus or minus the square root of b squared minus 4ac all over 2a. All you have to do is know that formula, figure out your numbers, and plug it in. So let's look at this. So this would be minus, our b is plus 6, so it's minus 6 plus or minus the square root of 6 squared minus, again, this is how I do this. I take my 4 multiplied by my a, which is minus 9, multiplied by my c, which is minus 1. And this whole thing is over 2 times minus 9. This I can rewrite as minus 6 plus or minus square root of 36, that's just 6 squared. Now let's look at this. I've got a minus times a minus, which is a plus, times a minus, which is going to be a minus sign. I do my sign first, and then I just do the number. So what's 4 times 9? It's 36, times 1 is going to be minus 36. And the bottom, 2 times minus 9 is minus 18. So this ends up being minus 6 plus or minus the square root of 0 in this case. And if we remember from the first lesson, the square root of 0 is 0. So that's going to basically just disappear on that side, right? I'm just Xing that out because the square root of 0 is 0. And then we have that over minus 18. So in this case, the plus or minus doesn't really matter because it's plus or minus 0. So this one time, it's nice to us. And we have minus 6 over minus 18 is my x value. And that is the same thing as, you can simplify that to 1/3. In this case, and we'll look at this graphically in a minute, or how this happens, but this is one case where there is only one solution. Because the positive and the minus are the same thing. Over here, the quadratic equation, while nice, also can be a lot of work if you keep ugliness involved. But we can remember our very early rule about solving equations in general, algebra, which is if I've got that ugly fraction, I can multiply both sides of my equation by my lowest common denominator to get that fraction out of there. So I can actually make this into 4m squared minus 2m plus 3 equals 4 times 0 is 0, right? So now we've got a standard form. Now I can plug it in. What's minus 2 plus or minus the square root of minus 2 squared minus, again, I write my 4 times my a, which is plus 4, times my c, which is plus 3. And this entire thing, oh, don't forget that first minus sign. That entire thing is over 2 times 4. This equals 2 plus or minus the square root of minus 2 times minus 2 is 4 minus, and now I've got a plus, and a plus. That means it's going to be a minus sign. And 4 times 3 is, that's going to be 48. And this is over 8. So sometimes these can get a little bit ugly. Now we've got 2 plus or minus the square root of minus 44 over 8. We're getting there. There's just a little bit more rearranging to do now. This is the same thing as 2 plus or minus. Let's rearrange this this square root of minus 44 using the stuff that we know. Let's think about for a second what the square root of minus 44 is. If we simplify it, it's the same thing as the square root of minus 1 times the square root of 44, which is the same thing as the square root of minus 1 times the square root of 4 times the square root of 11, because we want to reduce this by taking out the largest perfect square factor, which is the square root of 4. I hope you guys remember that. This turns into 2i, the square root of 4 is 2, the square root of minus 1 is I, times the square root of 11. That's what that becomes. Plug that into there, and you have 2 plus or minus 2 times I times radical 11 over 8. We're almost simplified now. We can turn this into a polynomial. This is the same thing as, or not turn it into a polynomial, but look at the two different terms there. This is the same thing as, we can factor out 2 from this. So it's 1/4 plus or minus 1/4 I radical 11. You can actually calculate this, because that's an imaginary number, so this doesn't have a numerical value, but that is what x is in this case. Okay, that's all there is to this. It can get ugly, and that's why I would suggest you use completing the square if you can. I would even probably look at this and probably try to solve this equation by completing the square. But if you're afraid to do that, you're not used to it, then you can always use the quadratic equation, as long as you make sure that you're not making mistakes with your calculations. That's all it is. Okay? So it's a useful formula. It's very useful, but there's a lot of plugging and potential for error. And remember to reduce your answer to the farthest it can be reduced to or simplified to, just like this down here. Okay, that's the lesson on the quadratic formula. Next, we're going to look at some, basically, let me see for a second. We're going to look at some applications, some extensions of this. Now we're going to basically think about how quadratic equations look graphically and what that means. And that's going to be the 4th video in this series, and we'll go from there.